so I think I'm good now. So hey everyone, hope you're good. Okay, find X, I assume. I was too focused on your reaction. Oh, well here, let me... Someone was probably gonna snap it up, but... I think... I think we want to engineer it so that the 4 and the 6 are together. That's my guess here. Maybe you could even take the log of it right off the bat, just as it is too. Are you going back to bed? All right, Shep. Rest easy. I think my red marker is the only one that is really actually working. I give it up on the rest. Well, yeah. So we have to deal with the 1 minus x exponent, but once we do that, I think want to get the 4 and the 6 together. Oh, like that. That seems like it's making it harder. Well, I guess because you do have the 3, you do have the 2. I'm gonna do it the way that makes sense to me, but well, you're saying probably is a way that you can do it too. I'm gonna make this 6 to the 1 minus x equal to 6 to the 1 over 6 to the x. This is equivalent. The right side will stay the same. Then I want to multiply by 6 to the x on each side, because to me this is the most direct way to do it. Then I'm going to divide by 3, and I'm also going to group these into 4 times 6 to the power of x. In parentheses, that's what that is. And then we get 2 equals 24 to the x, and now, oh, that's going to be a weird number. I guess we take the log. Log base 24 of 2 is equal to x. And then you can evaluate that. I mean, you kind of need a calculator unless you want to do an exact value. Log base 24 of 2. .21. Oh, it doesn't really like. Yeah, you're right. Or I don't know why you're right, but I guess I'm talking to Wolfram right now. It doesn't really simplify it to anything further. So I guess the answer is just log base 24 of 2. You could plug it into a calculator and get the decimal, but it's not really necessary. And so, Jan, if we did the way that you're doing, we're going to have 3 things, or I guess we'll only have 2 things that are to the power of x. It just feels like it's making it more complicated than it has to be, though. It probably also works. Well, no, because we're going to get 3 to the x plus 1, I think. And that seems like a pain to deal with. Well, that's really not. Okay, fine. Well, let's look at it. Instead of me guessing. If we instead split this up into 2 to the 1 minus x times 3 to the 1 minus x equals 3 times 4 to the x. I guess from here, like, do we multiply by 2 to the x and by 3? I mean, that's like kind of the same thing, though. Or it is the same thing. So the 2 does go into the 4, and the 3 does go into the 3, but... I think it basically is going to boil down to doing the same thing that I did. I don't see a completely different way to do it. Two to the 2x, but you can do that. But I don't think that's going to help you either that much. I don't know. Oh wait, Alcalander wants to do the same thing. I don't really see where you go from there, though. I'm going to post my way because I think my way is a lot more intuitive to me. So 6 divided by 6 to the x. By 6 to the x and divide by 3, you get 2 equals 4 to the x times 6, to the x. From there, you can multiply, or you can, I'm going to say combine the 6 and the 4 and put it into logarithmic form to solve for x. It's probably right too, so I'll upload them, but my way seems, it feels to me much more direct. It might just be like, it depends on the person thing though. Got a question? Okay, Jed? Huckleiner got to this one. So wait, it was this form, right? But with the 2 to the 2x? Can you divide both sides by 3? Yes. You would end up 1 minus x minus 1 is just 3 to the minus x. And it's kind of a mess of exponents. Like, you can solve this. You could divide by 2 to the 1 minus x, or I guess by 2 to the 2x. Oh, you want to divide by 2 to the 2x. Okay. Yeah, let's try that. 1 minus x minus 2x is 2 to the 1 minus 3x times 3 to the minus x equals 1. You can divide by 2 to get rid of that 1 in front. I don't see how you relate the 3. I guess you can make it 8. Okay, yeah. So first off, divide by 2 to get rid of that 1. 2 to negative 3x times 3 to negative x equals 1/2. Now 2 cubed is 8. 8 to negative x times 3 to the negative x equals 1/2. Now you can combine the 8 and the 3 because they have the same exponent. 24 to negative x equals 1/2. And then you do get the same thing. So you can raise each side to the power of -1 to get 24 to the x equals 2. So you do get to the same answer with that method. It just looks like so much more of a mess to me of exponents. Total of 83 teens attending performing arts camp to train in at least one of 3 activities: dance, acting, or singing. Oh, it's one of these like Venn diagram ones. Hmm. Yeah, Jed, you're right. Okay. How many teens trained in only one performing art? So let's just say dance, acting. Shouldn't this be dancing if that's acting, and if this is singing? Anyway. So now we need to start filling in information that we know. So 15 took dance and acting only. Okay. So dance and acting only. That means we have a 15 in this intersection. 12 took dance and singing only. Okay. 69 took acting or singing or both. So we know in total this plus this has to equal 69. We don't know, or plus the middle. Oh no, but not all three? I guess not all three. 9 took all three performing arts. Okay. Ben, how's it going? AUS equals 69? Or, okay. Oh, acting union singing. But that doesn't include the triple intersection, I guess. Isn't it vague? It does? I guess so. Yeah. Um, so say, okay, so how many took, 50 total took dancing. And we know the 50, if we want to find just this upper part of the circle, we do 50 minus 9 is 41, minus 12 is 29, minus 15 is 14. Okay. Do we have enough information to solve the bottom bubbles? Fifty took acting, 44 took singing. And I guess if we're saying 69 took 1, 2, 3, 4 parts of the bubble, minus the 9 that we know. So there's 60 remaining for the 3 last ones. Oh, I was... Well, okay, you're right. That makes it harder, though. Now, because we do have to include the upper parts for the like acting or singing or both. Well, no, that doesn't include dance. Well, I guess it does technically, if we're counting the middle one. I don't know how we relate them though. Like, I guess if we do the 69 to acting or singing or both, make an equation out of that. It'd be 69 minus 9 minus 15 minus 12. 60 minus 15 is 45. 45 minus 12 is 33 equals A plus S plus AS. I'll say A intersect S, I guess. Well, A intersect S minus the middle. I'm just going to say that's AS. X, Y, and Z, that's probably more clear, yeah. Let's do that. And then I guess we do... Acting is 50 total. So 50 equals x plus y plus 15 plus 19 plus 9. Then singing is 44 equals y plus z plus 9 plus 12. I guess that is the equation's three unknowns. Let's get rid of these two like parts of the numbers first. 50 minus 15 is 35. 35 minus 9 is 26. 44 minus 9 is 35? Didn't I just say those? No, never mind. Okay, that's just a coincidence, I think. 35 minus 12 is 23. Okay. Did you use the first one? Oh. If we subtract this equation from that one, we can isolate z, I guess. Uh, 7 equals z. Okay. And then if z equals 7, we can plug it in up here. And get y equals 16. And then that means x is 10. And so we can verify this by adding everything up. 10 plus 16 is 26. Plus 7 is 23. Wait, 33. 33 plus 15 is 48. 48 plus 9 is 57. 57 plus 12 is 69. 69 plus 14. 83? 83! Oh yeah, I just cut out the arithmetic for that first equation. Okay. Yeah, I mean, I didn't think we'd have to use a system of equations there, but looks like you do. I use it just to verify the answer. I hate when people delete their questions. All right. So this one, we don't even have to go to the whiteboard. So if you have a squared times b squared, you can say it's equal to a times b squared. You ever plug your Twitch in the comments of these? No. I like on my Reddit profile, I have a little thing that advertises myself if someone were to click through my username, but I think that wouldn't be cool to advertise myself. Ben, other Ben, how's it going? People have actually wait, Ben Stormzy, do you also stream? I don't want to leave you out, but Ben one has arrived. Yeah, not really. Oh, okay. Stormzy's Ben too. Okay. So people I figured out that I stream before, but I never really advertise myself on these forums. I feel like it's not cool. Always, you're probably not supposed to do it. So, in this situation with 1,000 squared, shout out to me. Thank you. Times 120, we don't have the squared on the 120, but we can force one to be there. Since a is equal to a, or, oh, actually, let's use their square root symbol. Square root a squared. Are you with first order linear differential equations? I can do those, like with an integrating factor. I usually need to look up the formula again, but they're pretty like, it's pretty much always the same technique. Well, sometimes you can also do separation of variables, but I'm pretty good with them. Actually, let's not use A, let's use 120. Even do 1.5 order ones. They're also complex. Now that's probably outside my area of expertise. I can still do like, I mean, sometimes the calculus just transfers over normally. But I don't know if it, like the situations where it doesn't, or if you have to do something special. I like a challenge, right? I guess it sounds like you have a problem if you want to post it. So we can say that 1000 squared times 120 is equal to 1000 squared times square root 120 squared equals 1000 times square root 120 squared. Okay. It's a lot of exponents, but there we go. Find the complete solution to z prime of t equals 3zt minus 65e to the negative 1 plus 3it. I bet this would be just the same as if it was a real valued function. I feel like it would be. I don't know. I probably shouldn't just assume that, but let's see. These frickin' markers don't want to stay in place. I should just let them stay horizontal because they're pretty much dead anyway. Okay. The complete solution. So what if there's going to be like infinitely many? That might be something that gets me tripped up. C prime of t plus 3c of t. Is that minus or equals? (65e) the negative 1 plus 3it. From the vertical, you should tie balloons to the ends. Apparently. So we could say it might be equal to 0. It is equal? Okay. That's the equation these are, or that's the format these are normally given in anyway. You had to zoom in. Oh, okay. So let me bring up, looked like a minus. Oh, I see, yeah. I do need to refer to Paul to get the formula for the integrating factor again, but I assume we could just use it without that much of a worry. And if I know your professor has been teaching it, to see if you can do a better way. Okay, I mean, I can't promise this is going to be right, but I guess we'll be able to verify at the end. It's interesting, when you have the constant in this case is a complex constant, I guess. I don't know if that's really that significant, though. With the guess method? Oh. I don't know if I'm a fan of that. I mean, obviously I haven't done differential equations with a complex function, but It's e to the p of t, and p is the one on its own on the other side of the equal sign, I think. No, it's the one, really? It's the one that goes with y. Okay. So first we're going to get the integrating factor here. You don't like having to guess in math? I mean, it's kind of it's like with the differential equations, it does kind of become guessing a lot of the time, but it's like, it's not really guessing, but it's like, I don't know how to describe it. You basically, like you get taught it in a way where you don't have to guess, but the initial thing is actually a guess. Like if you have y prime is equal to y, you can see intuitively that this should be e to the x, because e to the x is equal to its own derivative. But there's technically no reason why it couldn't be something else, as far as I know. Maybe we proved that only e to the x can work for that kind of differential equation, but I think except for some situations where you can prove uniqueness, like there's no reason why it couldn't be something else that you didn't even think of. Anyway, the default way I was taught to solve first order linear differential equations is with an integrating factor, mu, and it's always equal to e to the integral of p of t. Sometimes it's usually p and q, and p is whatever function is in front of your z in this case, which in this case we just have 3. We could have something with t, that'd be fine. But here we just have 3, so it's e3 integrates to 3t, and we have to add in our constant. Speaking of y prime, any primers in chat? I appreciate that. And then now with the integrating factor, we basically have a formula that we can plug it into, which is 1 over your integrating factor times the integral of your integrating factor times g of t, basically whatever is on the outside of the equal sign. They do the minus c there, which is that's kind of interesting. It's extremely different. I guess we'll see how this next step shakes out. But basically using the formula, z of t is equal to 1 over that, our integrating factor. I don't know. I might not do the plus c there because I feel like that's doing a different way than I was taught. The way that Paul's notes has it. So I usually would do the integrating factor, or the constant of integration with this integral. Inside this integral goes the integrating factor, e to the 3t, times whatever's on the right side of the equal sign. -1 plus 3it dt. That looks like a pain. We can take the 65 outside. E to the 3t integral. And then these are the same base, so the exponents add -1t plus 3t is 2t. So 2 plus 3it dt. Okay. Then, when we integrate this, we have to do a u sub. Basically, we just divide by whatever's in front. Again, this is all just me spitballing, treating, like, basically pretending like the I isn't here, except when I have to acknowledge it, like here. So 2, well, that's not 2 at all, is it? 2 plus 3i e to the 3t. Wait, we already integrated. Times, oh, just e. 2 plus 3it. Now I'll do the plus c. And actually, we do need parentheses here, because the c is going to get a function to go along with it. Okay. Now, I guess we want to multiply this stuff inside the parentheses. 65e to 2 plus 3it over 2 plus 3ie to the 3t plus 65 times c. I'm just going to call that c. It's a constant times a constant. e to the 3t. And a constant divided by another constant here. Actually, I can remove the 2 plus 3i as well, assuming that c is complex valued, which I would think it is. Okay. And now I just want to combine these two functions into one. So I guess doing the same thing that I did over here, we have 2t minus 3t is negative 1. Actually, I'm going to write it so the constants are on their own thing. 2 plus 3i e to negative 1 plus 3i t plus c e to the negative 3t. I'm just going to bring that e to the 3t up. So I guess that would be the final answer with this way. No idea if that's right. I don't see anything else that you can do with this, at least. No? Some are the same, some are not? Oh, okay. Check Discord.
You are technically correct. The best kind of correct.
Thank you, Spurskin. You always believed in me. I'm gonna bring this up on the stream too. Just the image. And then just so we can all see the math, the translation, we get a particular solution that looks like the right side. And this is put into a differential equation to get this. The rest is basically nothing important. K is the constant instead of C. So, okay, this is our guess. Oh, using a particular solution. Ooh, really? This is a... I actually got almost the exact same thing. The only thing that's different is this part out here. I said that was 65 over 2 plus 3i. This is just 10 minus 15i. So I wonder where that came from. You guys shouldn't have skipped ahead so far. But this is almost a technique that was taught to me a lot later for, I think, second order non-homogeneous equations. Yeah, no, I'm sure it's right. I'm gonna to that 65. I should probably just follow it from top to bottom rather than going straight to the bottom. I'd assume it's Danish for Ben. Yeah. Oh, this is literally doing... Okay, I see. So we assume that the solution is this, and we're really plugging it into the original differential equation. So this right here is z prime. This is 3 times z, and this is the 65 plus that. And this is how you get k, the constant. Oh. I think no, Luigi. I wonder... That's an interesting way to solve for it that I haven't seen before. This really isn't going to... Well, ooh, I guess this technique would get really tricky if you don't have E functions. Like if you had a sign thrown in there, I feel like it'd get really hard. But basically, this solution was just a constant times e to the negative 1 plus 3it. I wonder if there's a way that I could have made this work, because I am very close. I wonder if I just missed something. We actually Oh, wow. Okay. I feel like that would get really weird. Oh, wait. If I did the complex conjugate, I have 65 over 2 plus 3i. But I'm looking at this step right here. They do have this. But they multiply the top and bottom by that. I guess, oh, because they, not rationalizing the denominator, but they get rid of the I in the denominator, whatever that term is. So I just want to see if, I think I did get the right answer then. Because basically what they did, I did get that, they got the same thing there, but they multiplied the top and bottom by the, oh my God, the conjugate? And when you do math, which I don't know how to do, but if you try to do the math, 4 plus 9 is 13. And 13 times 5 is 65. So actually, this does get the right answer. I just didn't fix my denominator there. That's cool. It's still called rationalizing? Okay. Okay, so yeah, I guess it seems to work for complex valued functions too. I wonder if there's a situation where it wouldn't work or you have to do something special, but we can look at that one too. Yeah, sure. um, and that one, it looks like all the numbers that were given at least are real. I is not rational. Oh, that makes sense. Because it's square root of -1. I'm also not rational at all, Luigi, so me and I have something in common. Okay, so we have y prime of t is not equal to. Well, actually, let me write down the like general version of this just so I can show you like what the actual formulas are without just glazing over them like I just did. So if you have a differential equation in this form with a y prime, a y, and then a function there and a function there, well, I guess it'd be plus, but it's not too important. Your integrating factor mu is always e to the integral of p of t, that function. And your solution, y of t, is 1 over mu of t times the integral of mu of t times q dt. And you do need to remember to have like parentheses and a plus c, but that's basically how the technique goes, is plugging into that formula. The most beautiful math equation in the world. I can look at that too. Should I do this problem first, or look at that? I don't know how to figure out why it's the most beautiful. Oh God, okay. Don't open the vid. Okay. 17 sine of 4t. Okay, I guess I'll do this first unless you want to post that, but we have an initial condition, y is 0 equals -3. Okay. So for this, doing the same thing, let's find our mu of t first. In this case, our function before the y of t is -1, or minus dt. So our integrating factor is e to the minus t. Plugging into our formula, we get 1 over e to the minus t times the integral e to the minus t times q, which is 17 sine 4t dt. Oh gosh, it's going to be one of these integration by parts. Okay. So let's bring the 17 outside. And the e to the t can come up top, so it's a negative power. This is going to be a little bit annoying to integrate by parts. E to the pi I plus 1. Oh, it equals... No, it's e to the I pi minus 1 equals 0. When it's plus 1, it would equal 2? I guess I can look at it after, but I assume it's just Euler's identity. But yeah, I guess this one is going to be integration by parts. Okay, so sine of 4t, just rewriting the integral part on its own. This integration is, or this, I guess is going to cycle. I don't know which one we want to integrate, which one we want to derive. It might not actually matter. There is like the quicker like DI method that I always forget how to do it, so I'm just gonna do it the old-fashioned way. So I'm gonna, I guess it doesn't actually matter. I'm gonna, I'll derive the sine. Sine of 4t, and I'm gonna integrate e to the minus t. You can do either, and I think you'll get to the same thing though. Deriving you get 4 cosine 4t dt. Integrating that, you get v equals minus, minus e to the minus t. Now you do uv minus v du. That's how I always remember, I draw that little like arrow thing. Minus e to the minus t sine 4t minus v du. We'd have a minus sign there, so that becomes plus e to the minus t times 4 cosine 4t dt. Now we don't know what this is, so we need to integrate this by parts. What's the solution professor gave? This one so you can check after. Oh, good. Thank you. Okay, so now let's integrate this by parts. We'll do the same thing, but we have a cosine there instead. U is, I'll put the 4 outside as well. Actually, I shouldn't do it like that. I'm just gonna remember to put the 4 outside. U is cosine 4t. I don't know, it's really not that important. I could have the 4 right here. I should put the 4 right there, so I'm gonna forget about it. dv is e to the minus t dt. du, deriving that, we get minus 16 sine 4t. v equals minus e to the minus t. Okay. uv minus v du. Minus, actually, wait, we need this first part here, though. That was a plus sign there. Okay, so bringing that first part down, minus e to the minus t sine 4t plus uv, so we actually have a minus now. 4e to the minus t cosine 4t. And then now the formula would be minus there. And we have 2 minuses, so we still need a minus there. v du e to the minus t times 16 sine of 4t dt. Now, here's where the trick comes in, finally. Let me actually rewrite this. I'm going to bring the 16 outside the integral, because now it is actually important for my next trick. I said this was minus, right? Yeah. Okay. Now, we have, this is all equal to e to the minus t sine of 4t, and we have an e to the minus t sine of 4t here. So what we're going to do is we're going to add this 16 e to the minus t sine 4t to each side. It's going to group with this all the way up here. And we're going to have to divide by 17 because 16 plus 1. So integral e to the minus t sine of 4t dt is equal to 1 over 17, then whatever's remaining. Minus e to the minus t sine of 4t minus 4e to the minus t cosine 4t. Okay. So after all that work, we know the result of this integral here. Sorry for the terrible translations. No worries. It's already looking close. Okay, good. You know, we are going to get a nice simplification here, at least, to console myself. So we have the 17e to the t. Oh, hey. We have 17 and 1 over 17 getting multiplied together, so let's just forget about those. And while we're at it, we have e to the t times e to the minus t. So that's just going to equal 1 as well, so we can actually forget about those as well. So I think we just end up with... Oh, wait. There's one little trick, but I'll get to that. I'm going to do the plus c here, because the 17e to the t does get multiplied by the c. But the 17e to the t will cancel with the 1 over 17e to the minus t for each term. So we just get minus sine 4t minus 4 cosine 4t plus 17, and 17 and c can combine into just c e to the t. Okay, and so this is the function that we get in general. We do need the particular solution. I think that might be the right term, but we need to apply our initial value to figure out what c is in this situation. So if we know y of 0 equals -3, let's plug that in. So y is -3. T is 0. Sine of 0 is 0. Cosine of 0 is 1. So -4 plus c e to the 0 is 1. C equals 1. So our solution for this initial value problem is y equals minus sine 4t minus 4 cosine 4t plus e to the t. Okay. The integration was a lot of work, but so much simpler. I mean, yeah, this is just like a formulaic way to do these problems. It's kind of nice. And it looks like it matches. Let me bring this up too. Yeah, so we get the same last line there. Hell yeah. This is, I mean, if you're willing to do that guessing, I guess it's a lot less work than doing the double integration by parts, but this feels like it's very easy to go wrong and get confused. Yeah, this is the same technique where we guess the solution is some constant times e to the 4it, really? Huh. Yeah, exactly. This way that I was always taught, like this way makes sense to me, but I didn't know that it existed. Oh, but here you have a trick because huh. I don't know the part where the sines and cosines get incorporated, but oh yeah, sure. This is actually, this is the site that I always refer back to, but the way they explain it is slightly different than the way that I learned it. But basically, down here are the formulas that you would need. I'll send you the link. And the y equals 1 is what your final answer will be. Yeah. And so you want to see the e to the pi I plus 1 equals something, right? So we can figure out why it's the most beautiful equation in math. Yeah. Interesting, cool math problem. Yeah, sure. I think we'll get after this, no pro. So I'm a professor of mathematical science from Carnegie Mellon University. Interesting. Huh. I'm not sure where to go with that one, but let me think about this one first. So e to the I pi plus 1 equals question mark. So e to the I pi, I guess if we look at it on the complex number plane, isn't it just that? -1 real? We could do the cosine and sine formula. Cosine pi plus I sine pi. Oh, yeah. Plus 1. Cosine of pi is -1. Sine of pi is 0. So that equals 0? You don't see that? Yeah, if there's a 2 here, we might have them. That's correct, but why? Is it beautiful? Why is it beautiful? I mean, it just includes kind of like all the basic concepts of math, I guess. 0, 1, x, I guess e, and pi. Like, I guess it includes like a little bit of a lot of parts of math. That's why I've heard people describe why it's beautiful. I guess that is. Oh yeah, that is Euler's identity. I got to mix it. For some reason I thought it was -1 equals 0. Watch the vid. It's 3 minutes long. Yeah, sure. Explain things that I already know to people. Trying to learn new things on stream is just it's annoying because I just stare at it and not get it. Like with that cal part problem, it's really not that hard, but when I'm streaming, I have 5 different things I have to focus on at once, and I can't actually think meaningfully about problems. N dimensional rectangle with minimum perimeter of its area is 200 square meters. Oh, so this is a pre-calc student who's basically doing a calculus problem numerically. We want to minimize perimeter given a 200 square meter area. I think there's just going to be a square. I feel like the answer is usually a square. And so this person tried, it has to be a square. The perimeter is equal to 2x plus 2y the way the person did it. And if the area, which is 200, equals x times y, we made the relation y equals 200 over x and plug that in there. What is that? The reciprocal graph. I don't really mean by that. Let's actually graph that. 400 over x, because 2 times 200. I guess you can't minimize that. Oh wait, that's a minimum. (10√2). And that gives you a square, doesn't it? That's just the square root of 200. Yeah, it is. Okay, it is a square. Okay, they they did it right. Should look a bit like a check mark. The graph on the positive x-axis. A check mark, and the minimum perimeter occurs at the bottom of that check mark. Yeah, no, I said for the positive x-axis. I guess they are both check marks, but the other one is upside down. But you are right. Actually, I mean, that's kind of a check mark, right? I don't know. That's what it looks like to me. It's not really a check mark, but it kind of is. You should get an answer that is approximately 10. I'm just going to give the answer because they did this right. They just need to bring it home. 10 square root 2. $14.14. You're trying to prove for an even. I don't know. You prove it generally. I mean, maybe the first question actually more clear. I don't really like the positive x-axis. So actually, I do like that phrasing, Luigi. Thank you. And sorry about that. Oh, shoot. They do need the perimeter. Thank you. That's a save, Jed. Add save at Jed. They need the dimensions to find the perimeter, but so you should get. So actually, this is good because we're not giving them the entire answer. You should get a value that is approximately. This is the length of the x side, and you can then solve for the y side. Yeah. Solve for the y side and get the perimeter. Okay. I don't know. That's probably the most time I've edited a comment. The shape is a square because 200 divided by 10 root 2 is 10 root 2. I don't think Drew has that capability. I told him he's like about to get banned, but he just keeps on going. So, I mean, I told him that yesterday. Okay. I think this is a good enough explanation. So nothing else. I always did get that person help with homework, and I replied to one or two others before I went on this riddle kind of binge.